Hi everyone, it's Mrs. Brimlow, and today we're going to look at how you find the area of a shaded region using different shapes, but specifically circles. So this is page 12 in your packet. I apologize, I forgot to put page numbers before I copied it, but this is what the notes look like. If you don't have the packet, you can click the link for a copy of these notes, okay? So in these problems, our goal is to find the area of whatever part is shaded, but there's going to be some sort of interruption by another figure, okay? So find the area of the shaded region, show all work, including formulas and appropriate labels. All right, so our goal is to find, it's a little hard to see here because it's so light, but our goal is to find this area right here, inside this rectangle, but around this circle that's in the middle of it, or off to the side of it, okay? Now, I don't have a formula to find the area of this specific shape with the circle cut out of it. But what I do know is how to find the area of a circle, and I know how to find the area of a rectangle. And then to just get this space around it, I would subtract or find the difference. So this is a 3-step process. So step 1, I'm going to find the area of the rectangle, okay? So I write it like this so I know that the work I'm about to do is specific to that shape. So area of the rectangle. So to find area of a rectangle, we would do length times width. So they tell us the length and width are 18 times 12, or 12 times 18. And I'm just going to pull up my calculator. So 12 times 18 is 216 centimeters squared. Okay. All right, so next up, step 2, we have to find area of the circle. So that is pi times radius squared. We use 3.14 as pi, and they give us the radius, which is 4. So 4 squared. So 3.14 times 4 times 4 again is 50.24 centimeters squared. So step 3 is I need to find the difference in those areas to figure out what the space is that's shaded. So 216, I'm going to add 2 decimal points after that, minus 50.24. It's really important that you're paying attention to your decimal points and lining them up when you are trying to figure this out, okay? Otherwise, your answer is going to be thrown off. So when I go to subtract, I can't do 0 minus 4 or 0 minus 2, so I'm going to have to borrow. So I'm going to change this to a 5, change that to a 10, which I need to borrow again, changing this to 9 and then a 10. 10 minus 4 is 6, 9 minus 2 is 7, carry down that decimal point. 5 minus 0 is 5. Gonna have to borrow again, and I get 165.76 centimeters squared. So this is the area of just the shaded region, okay, which is what I wanted. All right, so I've got 2 circles this time. So I'm going to find the area of each circle, and then once again, I'm going to subtract to find the area of just the shaded blue part. So step 1, I'm going to find the area of circle 1, which is pi times radius squared, 3.14. I'm going to start with the larger circle. So 3.14 times 8 again is 200.96 centimeters squared. So now I'm getting area of circle 2, which is still using pi times radius squared, 3.14 times 3 squared. So move this up, I apologize. So pi times radius squared, 3.14 for pi, radius is 3. So 3.14 times 3 again. Oh, whoops, I think I typed something wrong. I apologize. I'm going to start again. So pi times 3 times 3. There we go. 28.26 centimeters squared. So then step 3 is to find the difference. So 200.96 minus 28.26. 171. So the area of the shaded region of the larger circle in blue is 171.7 centimeters squared. Okay. All right, last but not least, we're trying to find the area of the shaded part of the rectangle. And I know this isn't perfect, but sometimes images on the computer don't come out great. What I have here is a semicircle that I have to find the area of, which we're going to talk a little bit more about how we get those measurements in just a minute. So step one, I'm going to find the area of the rectangle. So that's length times width. So 8 times 12, which is 96 inches squared. Next, I need to find area of the semicircle, which is area of a circle, pi r squared, divided in half. Okay. Now, you're going to notice that we don't have any measurements for the semicircle that we can see that's been visibly written for us. So we have to use our knowledge of rectangles to help us figure out what we need to know. So I know that rectangles are made up of two sets of parallel sides. So this is 12, then the top is also 12, okay? But that doesn't help me for my semicircle. The whole distance here is 8 inches, so the entire distance here is 8 inches, okay? So that does help me because now I know that the diameter or distance across this semicircle is 8 inches. However, I only need the radius, which is half the distance. So if the diameter or distance across the semicircle is 8 inches, then my radius has to be 4 inches. Okay, so radius equals 4 inches, diameter is 8 inches. So now I can use this to find the area. So 3.14 times 4 squared divided by 2. And I'm going to go ahead and use my calculator now. So pi times 4 again, and then divide that in half, and I get 25.12 inches squared. Okay. Now step 3, I need to subtract. All right, so I need to do some borrowing. So 8807. So 70.88 inches squared is my area of just the shaded region. Okay. So in today's lesson, we reviewed how to find area of different shapes and then applying that knowledge to find area where we have these irregular shapes and just the shaded region of them. So go ahead and check out Canvas for your practice options. If you have any questions, please let me know and I will check